This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. This podcast series is sponsored by Allied Electronics and Automation, carrying the most automation and control brand names in North America. Now, the questions posed in this podcast series all come from automation technology users like yourself across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is, what are the best methods for keeping control cabinets cool in high-temperature environments? Now, not long ago, we recorded a podcast based on another reader question about the differences between standard and certified enclosures. So it's clear that as common and straightforward as enclosures may seem to be, users still have a number of questions about them. And just as a reminder, you can find this earlier enclosure podcast episode and all of our others on our podcast landing page at www.automationworld.com/podcast. And you can also find them on your preferred podcast platform. So to answer this reader question about enclosure cooling methods, we're speaking today with Steve Sullivan of Rittal, a supplier of industrial and IT enclosures, racks, and accessories. So, Steve, let's just dig right into the reader question about enclosure cooling. Based on your experience with enclosure implementations, what do you consider to be the principal methods of cooling electronics enclosures in high temperature environments?
Hey, Dave, thanks. That's a great question. Certainly some of the most common solutions would be either fans or air conditioners, but it's important to understand that these are used in total opposite types of environments. So fans, for example, do not cool air. Doesn't matter how big they are, how fast they're running, how many of them you put on an application, they only move the air. And it's going to be the same temperature in the front of the fan as it is on the back side. Actually, if you had some very sensitive kinds of measuring equipment, you would find out that you're actually warming the air when you do that. But regardless, so in applications where there are high temperatures, you need to find a solution that will cool below those ambient temperatures, because if we kind of go back to the fan example, all you're doing with the fan is taking whatever that ambient temperature is and moving it into the box and displacing that area. So with that in mind, you'll never get below whatever that outside temperature is. So if they're big fans, lots of fans, all you're doing is moving a lot of hot air into the enclosure. So what you're left with then is looking at solutions that either are refrigerant-based systems or that might use a cooling medium such as water or a Peltier effect. And examples of these would be, again, air conditioners or air-to-water heat exchangers. Now, another approach that kind of caught me off guard was I thought, well, certainly they don't buy a lot of fans in Texas because it's extremely hot, and they would not use fans in Texas. Well, that proved me wrong, because what they do there is so hot that the control enclosures are actually indoors, or they're in a trailer or a container that is climatized. And then they do use fans on the control enclosures to bring that cool air in and cool the electronics in those cabinets. So again, there's several different approaches to that, but I think when you're looking at high density or high temperature environments, you're looking at air conditioners or air to water heat exchangers.
So you described several different methods of ways to cool it and cool the enclosures effectively. But do these methods vary by the type of enclosure or the type of electronics housed within them?
So if by type of enclosure we mean material composition, like whether it's carbon or stainless steel or fiberglass, I would say no, it doesn't vary. If by type you mean like its function, for example, if it's an outdoor traffic control enclosure, or maybe it's a plant floor enclosure that's housing IT gear, then it does vary, and there are going to be certain preferences. Many times the type of electronics speak to how sensitive the equipment might be and how it needs to have required airflow or cooling either in BTU or watts. And so we need to take care of that most sensitive component in the enclosure of the panel to make sure that doesn't fail and then bring everything else down. Most likely the spec or the specification will tell us exactly what the cooling requirements are, probably even the enclosure type. And by type, I also mean the type of um, protection rating. So it may specify a NEMA rating or UL rating or an IP type of protection. And so then we have to gear the climate control to those protection levels to maintain it. And then another important consideration to keep in mind is that both the enclosure and the cooling device probably need to match either a NEMA rating or UL. So, for example, if we take a NEMA 4 or a UL 4 rated enclosure and we put a NEMA 12, let's say, filter fan on it or a solution like that, then the package or the panel now derates to the lowest protection level, which in this case would be 12. So that's just another thing to keep in mind.
One question just to back up, just to make sure I'm clear on. You mentioned in your response to my first question, you mentioned use of refrigerants, water cooled air, and some others. Do they all work equally as well, or do some work better in certain types of environments than others?
Yeah, then and that's a great question, and there are the important thing of understanding like what to use where is also the limitations of each of these devices. So an air conditioner, for example, will it's a closed loop system, so you're never bringing anything from the ambient air or whatever outside into the enclosure. But they've got kind of a maximum operating temperature, and then after which point they don't become efficient any longer. And that's in the neighborhood of maybe 131 to 140 degrees Fahrenheit, depending on the manufacturer and the technology that they use. So even though you want to use that in warm or hot environments, there's a limitation to that. And again, it's right around that 130-ish standpoint. So what do you use above that? You can use air to water heat exchangers because water has 4,000 times the thermal capacity of air. And so now an air to water heat exchanger you could use in the neighborhood of 158 to 163 degrees Fahrenheit. And then you've got effective coolingness in that range.
Okay. Thanks for clarifying that, Steve. So, the reader's question specifically referenced enclosure use in high temperature environments. But looking at the range of environmental factors across industry, can you explain the influence that environmental factors have on the type of temperature control methods that you would select? Coming off of your answer there about the different types and their effectiveness.
Sure. And since we kind of led with high temperature environments, let's kind of start with that. So high temperature, just how hot is it? Again, that's going to tell us, which product to best use. And then the other thing to consider are maintenance issues too. So, for example, with an air conditioner, you may have maintenance on filter changes, or you might have something that is dealing with condensation, and dumping water bottles, for example. So it's important then if you can get a solution that kind of eliminates that type of maintenance. Air to water heat exchanger, for example, once you mount this to the enclosure and you've got your cold water supply, very little maintenance whatsoever. So you're saving that on the back end. That kind of also points to the front end of this is how do you get your cold water in that air to water heat exchanger? So it has to either come from an existing water source, water loop that's already at the facility, or from a standalone chiller. And so, part of our product line at Rittal is not only the air to water heat exchanger, but to be able to support that with chiller applications that are kind of self-contained cooling units. So you certainly have certain products that play in other areas, but there's also contaminants like that need to be considered, like your dirt and dust and oils. Maybe it's a corrosive environment that affects your choice, because these also speak to longevity of the product or maybe maintenance costs. Is the environment hazardous? Meaning, is there a presence of explosive gases or combustible fibers or powders that could also influence the choice of product? Is the enclosure indoors or outdoors? If it's outdoors, we may need to consider the effect of solar loading on the enclosure. So the sunlight, and it even kind of ties into the color of the enclosure. Certainly, if it's a light color, it's going to reflect some of that. If it's a dark color, it's going to absorb some heat. But there's definitely calculations that say if it's outside, this is how much additional heat will be added to your climate control solution because of solar loading. What about temperature swings? You may be in an environment where even not even season to season, but day to day, you may have very cool mornings. It heats up during the day and the temperature drops rapidly at night. And now you've got issues with condensation. You have moisture that then is inside the electronics, and we certainly don't want to see that. So then you might have to deploy a heater type mechanism, or you could have both a cooling product and a heating product on the same enclosure if you have those temperature swings. And so you kind of want to mitigate that. One other point is on the cooler side of the equation. If it's cooler and we can use that cool air, that's where we kind of deploy fan solutions or another product called air-to-air heat exchangers. And all they're doing then is using that cool air and then blowing it or forcing it into the enclosure to provide cooling and displace the hot air that's in there. You may even not have so much heat loss that you can do a passive method, which would be like vents or louvers on the enclosure. And you see those many times on traffic control enclosures that are outdoors. Nothing active on those. They just have vents and louvers in them to dissipate what little heat would be generated inside of that. So environmentals certainly play a huge role in the climate control equation. And, if the ambient air, most people know this, right? If the ambient air is cooler than the enclosure, then that hot air in the box is going to dissipate out. And that's kind of good for us because that reduces our overall cooling requirement. The flip side of that's bad. If it's hot outside and it's hotter than what the cabinet is and the electronics inside of the enclosure, then that hot air is going to absorb into the enclosure and add to the component heat loss. And so now this compounds our problem, and it actually increases what's required for our cooling requirements. So yeah, there's a lot that goes into the environmental factor of understanding climate control.
Yeah, that's considering all those factors that end users have to consider, and based on your experience implementing enclosures in a variety of industrial environments, how do you advise clients as to how to determine the best methods of controlling temperatures in their electronics enclosures in their given environment?
Yeah, so I think certainly, having a basic understanding of what products are used where, and a lot of this just comes down to physics, right? And it's just simple kinds of things. But if you don't understand those basics, it's very foreign to you, right? And you certainly don't want to make a bad choice. So when it's decision time and when people are going to spend money, then I prefer to use software or applications to help advise a client. And they also, appreciate this as well. So I use Rittal Therm 6.6 software. If I'm at the office or I'm at home, and then if I'm on the go or I'm in the field, there's also an app. So on my mobile phone, then I'm able to use a Therm app to help figure out a climate control solution. A sister company to Rittal is called ePlan. They're a computer engineering software company, and within their portfolio, they've got something called ProPanel. That's some software that, as you design and implement the panel build, it actually shows component heat loss and where you might have hot pockets come up in the electronics enclosures. So those are some really cool tools. By far, I just use Therm 6.6, which is free download on our website. And by the way, it isn't just for Rittal enclosures. You can use this software to determine a cooling solution for any enclosure that's in the marketplace, just as long as it has, dimensions of height, width, or depth. I can use that very valuable information to figure out what's going on in the enclosure, where the heat's coming from, where it's escaping from, and then maybe in the end, it's going to tell me exactly what I need, product-wise, part number, quantity for a Rittal solution.
Well, thank you for joining me for this podcast, Steve. And please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.